Hello, and welcome to the Powering Electric Vehicles with Renewable Energy seminar. I am Melissa Warning, the Marketing Strategy Manager for EnTech Solutions, and let me be the first to welcome you to today's session. I am joined here with a couple of energy experts, and we are going to be talking through all things renewable energy as it relates to electrical vehicle charging. I would like to introduce now Mike Collum.
Thanks, Melissa. My name is Mike Collum. I am Strategic Account Director for FTI, which is the main company of which EnTech is a division of. And I've been with the company about 4.5 years, and I'm focusing on the EnTech Renewable Solutions.
And Wade?
Hello, my name is Wade Leipold. I'm Vice President of Solutions, and I'm responsible for our EV infrastructure program here at EnTech.
Great. Thank you. So next we are going to go over our agenda and what we'll be covering off on today. First, we're going to give you an overview of who EnTech Solutions is, followed by an overview of the EV market. We will then get into details on EV charging basics or 101. Then we'll discuss OEM charging infrastructure requirements. Next, we'll talk through EV energy challenges. Then we'll work through making your dealership a sustainable location, followed by scaling your EV charging network. And lastly, we will end with some financing discussion.
Thank you very much, Melissa. To kick it off, I'd like to just briefly go over our organization. And we have 3 brands that are all united under one vision, and each of these brands has expertise to drive that end-to-end value proposition for our customer. So the parent company is Faith Technologies Incorporated, and underneath that we have Faith Technologies, who's responsible for all of our engineering and pre-construction activities, along with our electrical contracting and construction, and the ongoing support and service of those builds with our ISHNs, who are electricians, technicians of the future. The second division to discuss here is Accelerate. Accelerate's responsible for our construction manufacturing. With Accelerate, we're providing assemblies to the field to create greater efficiencies and productivity, to allow for quicker installs when we're in the field, and have less impact for our customers, so they get a product up and running as quickly as possible to support them.
So EnTech Solutions, we have several different focus areas. I'll start with distributed energy. That's the systems that include solar, battery energy storage. They can either be connected to the grid or completely off-grid. EV charging infrastructure is really a developing area with all of the electric vehicles that we're going to be talking about today. Going in, the need to have power to provide energy for these chargers. And then asset management is a part of our company that actually will manage and own and operate the assets. So we'll actually own a microgrid. We can do energy as a service. We can do leases. We can do other financial models for those. And then lastly, sustainable fuels, which is mostly in the areas of renewable natural gas that we're into right now.
Thanks, Mike. And with that, just a quick picture of our national presence. You can see our office locations. We have a nationwide presence with over 3,000 employees, and the capability to engineer, design, and install electrical install in all 50 states within the U.S.
So now we're going to take a look at EV market drivers and what's causing all this electrical vehicle chaos or a lot of media attention around EVs. The first one is the rising concerns around emissions. Decarbonization is everywhere nowadays, and people are thinking about how they can do their part to reduce emissions, and EVs are definitely a piece of that puzzle. In addition, there's a lot of government influence between tax incentives, grants, and mandates. The big infrastructure bill that's in the works right now is going to have a lot of potential impact on EVs. That's just one example. OEM investments is another area or driver. Right now, there are 27 US EV passenger models available, with over 50 models that have already been announced. GM has committed 27 billion, Ford has committed 30 billion. There's also growing mainstream acceptance. For the long time, there was the Toyota Prius, and let's just face it, that car wasn't for everybody. There's a lot more models on the market nowadays to accommodate the needs of the customer, between small cars all the way up to large trucks. Charger network is really expanding to reduce that range anxiety, which is great. It's kind of the chicken and the egg game we talk about. Is there going to be more EVs on the market, but people aren't going to be purchasing EVs until there's the infrastructure to support it. And then last but not least is declining battery costs. Just to throw out a statistic to help you understand how much these costs have actually gone down. About 16% annual decline in the cost of batteries between 2007 and 2020. So they're coming down drastically, which is making the cost of these vehicles more comparable to your typical internal combustion engine vehicle.
So with that, I'd like to kick off the next few slides and talk about some of the items you should consider when preparing for EVs. To start with, looking at energy usage is really important. The vehicles take a lot of energy. Here's a quick graphic, couple models that are readily on the market right now compared to energy usage at a home. You can see between the two vehicles on the left-hand side, just charging those 70% of their overall capacity takes between 46 and 48 kilowatt hours, and about 4 to 5 hours in order to get to that state. You compare that to a home, and throughout a 24-hour period, your home typically averages about 35 kilowatt hours of usage. So this is something you definitely need to take into account when looking at EVs, and we have ways to work with you to understand what that energy impact will be and how we can mitigate some of those additional costs and demand. It's also important to take a look at the type of vehicle that you're going to be charging and what the use case is for that vehicle. This drives a lot on what type of charger should be used and how much energy is actually going to be consumed for that. And each of these vehicles have different power acceptance rates and work better with different levels of charging capacity. Starting on the left, you have light duty vehicles all the way up to medium duty and heavy duty. Typically, as that vehicle gets larger, the battery packs also become much larger and don't necessarily require, but work better with larger sized chargers in order to charge them in amount of time to make them useful for our customers, that they're ready to go when they need those vehicles. So keeping that in mind, it's really important to understand we have the right size charger, and then again, understand what those utility costs and the utility impact will be with that size charger. So now talking about what are the different chargers and how do they work and how much output can I get out of them. On the left side here, we've listed the 3 levels of charging that are currently on the market. The first 2 understanding chargers, standard charging, are AC chargers. So this actually takes an AC current, sends that AC current to the vehicle. The vehicle then has an onboard device, its onboard charger, that actually converts that to DC and charges the battery with that. So the very first is the level 1. This is 120 volts. This is basically you plugging your electric vehicle into a wall outlet. With that, you can hit charge rates of about 1.3 kilowatts to 2.4 kilowatts, and you get about 5 to 7 miles of range per hour. But again, very dependent on what size vehicle this is. This would be more relevant for a light duty type vehicle. So as you can see, not a lot of range based on that charging rate. Your level 2 charger will be a physical box that you would have mounted on the wall. This would take in 240 volt service from your utility or your home, and it allows a higher charging rate, typically between that 3 kilowatt to 19 kilowatt range, and will give you about 25 miles of range per hour. Again, very, very vehicle dependent. We then move to a level 3 charger, with the level 3 charger, these units tend to be much larger. You actually bring in AC utility to the charger itself, but the charger presents DC current to the vehicle directly to the batteries and bypasses that onboard charging with the vehicle, allowing for a much higher charging rate. So it's 480 volts in, and typically you can see between 20 kilowatts to in excess of 350 kilowatts for charging rates out of these devices. And with these different type of chargers, there's also different ports that help handle the connector that actually goes from the charger to the vehicle itself. The majority of all the automakers right now within the US, you'll see the 2 ports that we have on the right-hand side. This is except for Tesla, but the standard outside of Tesla really is the J1772 for that level 2, that AC charging, and then CCS1 for the level 3 charging. If you take a quick look at these ports, you will notice that the top half of the CCS1 is actually the J1772 port. That provides the overall communication and charging capacity for that AC current. The bottom 2 ports on the CCS1 are actually where that DC current comes through when we're dealing with those DC fast chargers.
Thanks, Wade. As we've talked to our customers, there are a number of challenges that we hear that they're facing and we're facing with them together, and they typically fall under one of 3 areas: either cost, resilience, or what we also call reliability, or sustainability, or some combination of those. So some of the feedback we're getting is that many of the major OEMs, and you're well aware of this in the industry, are requiring infrastructure development prior to orders being placed. The infrastructure is really what's behind those chargers that Wade just talked about a few minutes ago. And the size of the charger is going to directly impact the capacity of the infrastructure. If you think about a cell phone or a mobile phone charger, you've got different size charging bricks. You've got a small, a medium, a large, an extra large, and none of those typically require infrastructure upgrade in your home or your business, but they're providing faster charges based upon the amount of power that's being drawn from the outlet. So understanding your current electrical system, what you have today, is going to be key to understanding whether you can upgrade, adding some chargers, or whether you have to bring in some additional service, whether that be via standard utility or through some sort of renewables to augment the utility. Utility upgrades can be costly. They can also take months, if not years, depending on the location, to get the approvals and get the utility to actually come out and make those changes. So the first of those 3 challenges we talked about a minute ago is cost. And cost really can be broken into 3 categories. One being the capital cost, and then 2 different types of utility charges. Capital costs really are reflected in the cost that the utility is going to charge you to actually bring in service, the cost for a third party that would have to come in and do that, any power distribution panels you might have, the chargers themselves. That's all costs that you're going to be able to, you'll have to capitalize and depreciate over time. From an operational perspective, there's a couple of different costs that you'll see on your bill. One would be the energy chargers. That's your basic per kilowatt hour charge. It can be anywhere from 8 to 18 cents per kilowatt hour, and that's your usage. A demand charge can actually have a more significant impact on your utility bill, and that charge is based on the peak amount of power that you might draw either during a month or during a year, depending on the structure of your bill. And then you'll pay a certain amount of money for every kilowatt hour at that demand, kind of a surcharge. And the purpose of that demand charge is to make sure that the utility has the power to provide you when you need it. So you're actually paying for the ability for them to provide that to you. Now, what we're seeing with EV chargers is they are a new significant and sustained load. So all three of those, it's new. We've not really seen this before. It's a significant load, not seen since air conditioning was added to businesses, decades ago, and it's sustained. So when you plug in that charger, you turn on that charger to the vehicle, it's going to operate for several hours, and so you'll see that sustained charge for quite some period of time. So this is a graph that kind of shows the impact, and this is a graph that's going to show kilowatt hours and kilowatts. Don't want to get too technical, but the kilowatts on the left-hand side, that's really the amount of power that's being drawn instantaneously. And throughout a day, if you look at the green line, that's what you'll see in a typical day. Your peak demand is going to be sometime maybe midday, when everybody's there, when the air conditioning's running maximum. If you add a level 2 charger that Wade was talking about a few minutes ago, you add a couple of level 2 chargers, that's going to be about 50 kilowatts. That's the gray line. You add one charger would be the blue line. And all we're doing here is showing that the shape would be similar, but now that whenever that charger is operating, which could be for hours at a time, it's going to offset your energy usage up, and it's going to go up. It's not going to go down. And so the likelihood of you hitting a new demand charge is going to be nearly 100% chance of that happening. At this demand charge is, if you look at building A, it's basically got the same energy consumption all the time, day and night, and that's basically the peak demand. So that's not going to have a specific extra demand charge on the bill because it's always about the same. Building B will achieve its highest level of demand in the middle of the day. It'll consume less energy but pay the same peak demand premium as building A. And then in the scenario 2 on the right-hand side, what we can do here is, if you look at the stored energy, which is the green part, we can actually help to manage, and we'll get into this a little bit later, but we can actually help to manage that demand by shaving off the highest demand from the utility and augmenting that with some stored energy through batteries. Here's an example of a bill, just an example, but you'll see the two charges that are circled. The electricity consumption, or the kilowatt hour charge, is just under $3,800 for this particular month. The demand charge, which is based on a 15-minute highest interval during the time period, is actually more in this particular example than the energy use. So you can see that demand charge can be up to or even more than half of the bill, or said differently, it can actually more than double your bill. So the second challenge is resilience. And I like to often joke that is not the Bay of Maine that you see over there to the east of Michigan. That's actually the blackout that happened in the Northeast in 2003. I actually was in Connecticut at the time. We lost a large portion of the grid for a sustained period of time, hours to days in some cases. As we become more electric with our devices, with our vehicles, resiliency is going to be even more important going forward. It's not just the chargers. We have critical medical devices. We have cell phone communications. If you don't have a tower, you can't communicate through the towers. If you don't have power, you can't charge the phone even if you do have a tower. So the resilience is becoming more and more important as we become more electrified. And then lastly, specifically around EVs, when we go towards electric vehicles from internal combustion, we reduce the carbon emissions just based on the vehicle itself, not generating those emissions. However, it's not well known that we still emit up to 50% of the emissions of an internal combustion vehicle to charge those vehicles. Now, that's an average number across the US. If you're closer to where there's more hydro, it's going to be more sustainable. If you're closer to where there's more coal, it's going to be less sustainable. But overall, EVs reduce the carbon by about 50%. So as we look at how do we power these electric vehicles, initially, a lot of the vehicles have been powered directly from the utility. We basically connect a charger either to your home if it's a smaller charger, to a business. As we get to larger and larger chargers, the DC fast chargers that Wade talked about before, they're going to be drawing more and more power from either the utility or, in the case of what we're going to talk about more today, is renewable power solutions that can be provided, or even some combination or a hybrid solution of utility and renewables. So how do you charge EVs with renewable energy? Solar is something that we've all seen for a long time. Solar is applied to a lot of buildings, a lot of businesses, a lot of homes, and that can provide renewable energy, but it can only provide it when the sun is shining, obviously. And if there's no place for that solar to go, it may not actually be able to be fully utilized. So if we can store some of that solar energy that's generated in batteries, we can use that saved energy at different times. We can either use it at night when there's no solar. We can use it to do that peak shaving that we talked about before, or we can actually offset the solar to help to reduce the cost. And so basically, when you put together solar and batteries and the controls to manage it, that's something that we call a microgrid. So you may have heard that term before, but a microgrid is basically just a very small, almost like a power plant that you have on site that can either be independent using a generator for backup, or it can be tied to the utility grid to be able to augment the grid or to offset the energy that you're pulling from the grid. So the way our system works is that solar panels absorb the energy to generate the electricity to power the charger. Any excess power generated is stored in the batteries in a unit that we call Escape. That's our brand name for the system. And then stored energy is used to power the EV chargers when solar is not available, such as cloudy days or at night. Now, the other benefit of the system, if you connect it to the grid, is that any excess solar and stored energy can be used to power other operations, as we say, behind the meter. So what might happen is in the first couple of years, you might not have enough EV charges to cover all the solar that's going to be generated. So rather than having that solar be wasted, we can push that solar back to your building, and then you can utilize that solar for other parts of the operation. One of these systems can generate enough energy to charge one Bolt or Mach-E, as an example, about 480 times. Now, the likelihood of having 480 charges in the first couple of years is slimmer, and so therefore it's probably more important that we tie some of these to the grid to be able to utilize that, or tie it to your building, I should say, not just the grid, to be able to utilize that excess energy. So as I've kind of alluded to, there's two ways of looking at microgrids. There's an off-grid or a grid-tied version. Off-grid is completely independent from the utility. Sometimes you don't have access. Sometimes you don't have timely access, as we talked about before. It can be months to years to get the requirements met. But we can also get the system up and running in days with limited physical site disruption. Grid-tied, we can add on-site renewables and storage that can operate in conjunction with the utility. We've done this in a number of cases. When the chargers alone don't utilize all the sun, or solar energy, we can push that back. It also provides the ability to pull additional from the grid if the solar isn't sufficient. You can certainly do that with a generator in an off-grid situation, but if you look at Wisconsin in the winter, we don't necessarily generate enough solar on some of the December and January days to be able to fully power the chargers. So we do need some supplemental support on those during those months. This is an example of a system that is in operation today. So at Bergstrom Automotive, it's a Ford dealership in Neenah, Wisconsin. We have put in 2 of these systems. And what you'll see in the third picture over is the aerial view of the solar panels. There are enough solar panels here to provide power to 2 different escape units. You'll see one in the lower left-hand corner by the solar panels, and then you'll see one in the 4th picture on the right that's actually in the customer parking lot. The one on the left is powering the service bay charger. So we have in that situation, 1 charger in the service bay and then 1 charger in the customer parking lot. As I mentioned a minute ago, this will power or will charge, each of these will charge about 480 Mach-E's in a year. And the previous slide, you don't have to go back, Melissa, but the previous slide, the Bergstrom example is completely off-grid. So it has a generator, natural gas generator for more renewability. That is off-grid. This example, Road America, we put in another one of our escape systems with an EV charger. This one is tied to the grid. So much of the time, especially in the wintertime, Road America isn't racing. There's not a lot of vehicles there to charge. And so essentially that is a supplemental power source now for them. If you look on the building in the background of the leftmost picture, you'll see we have some thin film solar panels, very non-intrusive, different than the prior slide where we have the ground mount solar. Ground mount's faster to set up, lower cost, but we have many different options for the solar to be able to provide that energy production to the escape unit. And you'll see where the charger is mounted at the top of the hill here, physically separate from the escape unit.
Great, thanks, Mike. Now we're going to talk a little bit about marketing your sustainable charging. So I'm sure this comes to no surprise that there's been a rise of the eco-friendly consumer, especially during the pandemic. People have become a lot more sensitive to the environmental impact of their decisions, and a lot of companies are responding. You see a lot of sustainability reports and ESG reports coming out from big companies because they all know customers are watching how they're acting. So it's really important in this case to articulate that you are doing your part for a better tomorrow. So as Mike mentioned earlier, clean EV charging, when done from straight solar, is 0 emissions. So that's pretty incredible to be able to say, again, to reiterate what he had said earlier, if you're charging up based on a fossil fuel grid, you're only reducing your emissions up to about 50%, but this takes you all the way to 0. Solar powered charging systems like this can send a statement to potential customers that you care about the environment. A lot of people have drove by the example that Mike just shared at the Bergstrom Ford dealership in Neenah, and a lot of people have stopped and commented on the solar specifically, curious on how that's becoming a part of their dealership. So overall, thinking about using green power to lower electricity costs and greenhouse gas emissions and contributing to less overall pollution is definitely a statement that you can utilize for your dealership or your brand to really resonate more with that eco-friendly consumer.
Thank you, Melissa. So what is EV infrastructure? We've covered a lot in this webinar so far and a lot of different concepts and solutions that may be applicable for your business. When we take a look at EV infrastructure, we're really discussing everything from that utility meter until that port that goes into your EV. And we're here to be that one-stop shop, that easy button to support your solution, whether that is connecting to the utility or it's a grid independent solution. And we'll start with the modeling and engineering and design of that overall system, working with you, work through utility coordination, permitting, making sure that the right electrical distribution is there, installing that distribution and equipment along with the charger, and then starting up and commissioning that charger, making sure everything's working appropriately. And then with our highly skilled ISHNs, be able to support that from an operations and maintenance standpoint, look at preventative maintenance aspects and support it to ensure that it's always functional and ready for you and your customers. So if I take a look at our overall program approach to EV, we not only want to make sure that we're setting this up appropriately, given the appropriate solution for our customers right now, but also taking a look to make sure that we're there to support them in the future. Our common approach we have laid out here, we start with that initial assessment, understanding what the customer's needs are, what vehicles they're going to have, what size batteries those vehicles will have. We discuss what the right charger is for those vehicles, depending on how fast they need to charge their products, their cars. We're able to provide modeling for our customers so they understand what their current utility bill is. And then as they start charging those vehicles, what impact that will have, as Mike reviewed earlier, both from an overall energy usage and demand charges. And then we can talk about options to reduce or mitigate some of those charges, depending on what total cost of ownership would be and what's that appropriate solution. We'll then go through engineering, do a complete design. We're able to provide all the permitting, all the stamped drawings and permitting that's required to start building. We'll take a look at all the grants and incentives and subsidies that may be available from a federal level, from a state level, from your local municipality level, and help you apply for those grants and incentives if needed. Once that design's done and we have a formal proposal to move forward, we'll take a look at how best to source this. Should we use Accelerate? Do we have the option to build assemblies to allow this to install much quicker? Do we need to take into account of maybe needing to move this charging equipment in the future? So if we skid it, can we make it so we can easily disconnect it and move if need be? Maybe it's at a leased facility and we can't affect the overall property. We have solutions around all these different installations. Our team will then come on site, do all the final installations, making sure everything's to code and ready to go. And then our highly skilled team will go and continue on with that commissioning and startup, working with the charger manufacturer, making sure that everything's set up, and give you options as far as overall from an operation and maintenance standpoint. Do you want to own the charging equipment outright? We also have solutions where we can finance the infrastructure, use infrastructure energy as a service where you're only paying for the amount of energy that you're using. And then, as mentioned before, that continued operations and maintenance, providing preventative maintenance and any other items you may need to make sure that your charging solution's running at its best ability at all times.
Yeah, I just want to reiterate some of the financing options. So as we talk about these clean EV chargers, especially the Escape rapidly deployable system, there's a number of different ways to cover those costs. Energy as a service, which is basically paying for the kilowatt hour usage. Charging as a service, where we would actually just charge for a vehicle charge. We would own the assets in both of those cases. Thirdly would be more traditional owned infrastructure where you, the end user, would buy the system outright. We can provide services as Wade talked about previously in addition to that. Or lastly, there's rather than buying the infrastructure, we can lease the infrastructure. So then you still gain the benefits of the clean energy that's being generated. You're just paying for the equipment rather than the energy. And of course, as Wade mentioned, I'll reiterate too, is the grants and incentives that are available for the Escape system. What we've seen with a number of our applications is that between the investment tax credit at the federal level and then EV infrastructure credits, the accelerated depreciation for federal and state, depending on your tax bracket, you can reduce the cost of a system by about 50% from what it would be as, we'll say, off the shelf.
Great. Thank you, Mike, and thank you, Wade. That concludes today's session. You will see here our email addresses if you'd like to get in touch with us to have further conversations. But we really appreciate you watching this session and hope you found it educational. Thank you.
Thank you.
Thank you.